Hello, everybody. Today we're going to be talking about using the Pythagorean theorem on a graph, on the coordinate plane. What we can do is we can use the Pythagorean theorem to find the distance between 2 points, between point A and point B along this diagonal line. Now, normally on a graph, we can just count along these horizontal and vertical lines. But when we have a diagonal like this, we can't count along this diagonal. So what we can do is use those horizontal and vertical lines to create a triangle. And when we create a triangle like this, it becomes a right triangle. And those right triangles can use the Pythagorean theorem. Because your horizontal and vertical lines are always going to make a 90-degree here. So whenever we draw two lines like this to make a triangle, we're using two legs. And we're creating two legs, which makes this line the hypotenuse. So now, if we have a hypotenuse and two legs for our right triangle, we can set up our Pythagorean theorem. So if we use our Pythagorean theorem for our two legs and our hypotenuse, we can count along these legs because they're on the vertical and horizontal lines, and the hypotenuse that we can't count, we can solve for. So whenever you're using the Pythagorean theorem on a graph, you're always going to be looking for C, the hypotenuse. Okay, the legs we don't have to look for because we can just count them. But for the hypotenuse, we'd have to figure it out. So A squared on this one, let's count this up. 1, 2, 3. So now I'm going to replace A squared with 3 squared. And my green leg, 1, 2, 3, 4, 5. So now I'm going to have 5 squared here. So now I have 3 squared plus 5 squared equals C squared. Okay, so now I'm going to square my numbers. 5 squared is 5 times 5. That's 25. 3 squared is 3 times 3, which is 9. And now I have 9 plus 25 equals C squared. So now 9 plus 25 will be 34. And that's going to equal C squared. If you remember, last step here, what we're going to need to do is square root. So we're going to square root these numbers. Square root the left side, square root the right side. So now we have square root of 34. I don't know what square root of 34 is off the top of my head, but I know who does know, and that's Google. So I'm going to go to Google, square, if I can spell it right, square root of 34. And square root of 34 is going to be 5.83. Alex wants us to round it to the nearest 100th place. That's where the 3 is. So is the 0 big enough to round the 3 up? That's a no. So it's going to be 5.83. And I'll go back to my problem. And so my final answer here will be 5.83, which you can see there's no way we would have been able to count 5.83. Okay, we can't count that distance. The 3 and the 5 we can count, which is how we can go on from our Pythagorean theorem this way. So now we have our answer is 5.83. No matter how these triangles are set up, you can always draw a right triangle. So if I take another one, sometimes I drew the last one kind of underneath the line, but if I wanted to, I could draw it above, be on the other side. And the lines are going to be the same space if I just flipped them over. If I drew the same line down here, it'd be the same length. We'd count these two, 3 for green, 1, 2, 3, 4, 5, 6 for red. So now we'd have 3 and 6 for our legs, and we'd have to look for that last leg, the hypotenuse.